Hi, everyone. I'm Christine Hermwan. I've interviewed a ton of companies about their experiences with ANRs to develop our ANR feature, and I'm excited to share their insights and best practices with everyone here. I'm going to be focusing more on the business aspect of things, and for the more technical side, I'll let Ed introduce himself.
Hi, everyone. I'm Ed Chen, Senior Systems Engineer at Embrace, and I'm excited to show you our new ANR feature.
So first, why are we all here? ANRs affect Google Play Store rankings, and they're extremely difficult to solve. If you're a CTO or a VP of engineering, you know that the ANRs are a direct factor in your Google Play Store ranking, and your Google Play Store ranking determines your visibility, which in turn determines your revenue. So if you're here on this side of the house, I want to hopefully you come out of this one understanding a little bit more about ANRs and understanding, I think, the difficulty of solving it. If you're a mobile developer and you're here, you're the one that's been tasked to fix it. But the tools that you currently have at your disposal aren't enough. And so what I hope you guys get out of this webinar is one, having better technical tools to solve these ANRs, but also understanding the business aspect of it as well, and taking those things into consideration when you're deciding when to fix and how to fix an ANR. So this is the agenda for today. We'll talk through what's an ANR to get all on the same page, what the impact is, why it's hard to solve, and what's a better way to solve ANRs.
Okay, great. So what is an ANR? ANRs, an ANR represents a frozen user experience where they can't use your app. You might have microprocesses that effectively make your app appear slow, sluggish, or even busted. So I pulled these quotes from the Android developer docs to make this slide. And let me just read the first part of it. ANRs are a problem because the app's main thread, which is responsible for updating the UI, can't process user input events or draw, causing frustration to the user. The main takeaway from this slide is that your app will go into an ANR state when the main thread is too busy. Additionally, Android will wait 5 seconds before it registers this ANR condition. Christine, let's talk about the impact of ANRs.
Awesome. So what is the impact of ANRs? As I mentioned before, and as you can see in this image, there is a big difference if you are in the top 5 ranking, especially if you are a game and you drop down to something ridiculous like 200. This will greatly decrease your revenue. And why does the Google Play Store even come into consideration when talking about ANRs? The Google Play Store has factored ANRs into their formula or their algorithm when they are ranking apps. And to take a step back and understand why, first, a lot of people, when it comes to downloading an app or especially a game, they're browsing. They're looking for something like top free games or top fun games, and they don't know what they're going to get. They're relying on the Play Store to rank these games or these apps appropriately. So when they pick something from the top 5, they have a good experience. And so if a user picks the top game and it ends up being slow, it has ANRs and freezes, it's crashing, they're not going to have a good experience. If they go to number 2 in the store and they have a similar experience, they're essentially going to stop coming to the Google Play Store to download games, which in turn means less revenue for Google. So what Google wants to do is align the incentives of producing a good user experience. And the Play Store ranking enforces that. It enforces mobile developers and app developers and game developers to think about the user experience when it comes to developing these apps. So one of the major things that we know is that ANRs actually affect your ranking. And so in turn, ANRs have a more direct correlation with your bottom line than something else that, you know, people may talk about, like poor performance. In general, I think all app developers, all game developers really do want to optimize for a better user experience. Not just because of the Google Play ranking, but because there are other effects of having a poor user experience. If people are having freezes that are taking 5 seconds, 5 seconds is pretty long time, especially for the attention span that people have on mobile. They're going to leave your app. They're going to be less engaged. You're going to have more customer churn, and they're going to have fewer in-app purchases. On top of that, if you are a game, this has a lasting impact on your brand perception. If you have negative app store reviews, someone has played your game and it was a really bad experience, if they go back to browsing for games and they see another game made by your company, they may skip it. And so it very much is important for your brand and for future revenue that you optimize for a good user experience. And ANRs are one component to that, but because it is factored into your Google Play Store ranking, it is a much more visible way of looking at user experience. Just to throw this out there, I actually had a developer that talked about, you know, how he did not trust the Google Play Store rankings, but at the same time, he recognized that it was very important in the perception of the app in future games. So why are ANRs difficult to solve? First and foremost, I think all problems in mobile are just harder to solve. You have the first layer of your code that you've written, and as your team grows, there are more people contributing to that code, and you can't monitor every single PR. Next, you have other SDKs that add to your app. You have SDKs for marketing that are identifying attribution. You have ad providers. Their code is a black box, and you actually don't know what's written in their code or how it'll interact. On top of that, you have environmental differences and differences in devices. Network connectivity, if I'm walking through a tunnel, that will affect my experience, as well as even the device that I'm on, especially on Android. You have so many different manufacturers and you have users on so many different OS versions. So you take that all into account, and any problem on mobile is extremely difficult to resolve. So the main complaint that I get from most mobile developers is that there's a lack of information to prioritize, and also just a lack of information to resolve. So we'll talk first about prioritization. ANRs are categorized by methods. And so if you're not a mobile developer, the example that I've come up with is, imagine I'm polling this group and I'm asking everyone to tell me what country they're located in. Instead of writing country, everyone in the US writes their state. Now, if I'm trying to quickly at a glance, understand how many people are from the United States. I have to do this mapping and understanding of, okay, if you're from California, that's in the United States. Also, if for some reason it's a free-form document, you could have written California out, you've written CA. There's so many different ways of saying the same exact thing. And that's kind of how I view things when ANRs are captured by methods. It's very specific, and it's actually highly opinionated because it depends on the algorithm that Google Play or your provider that shows you your ANRs, how they think about who caused the ANR. We go through this algorithm, and even for us, our first iteration of ANRs, we tried to look at a line and say, what is the likelihood that this line caused the ANR? So it's our opinion on it. And then the second aspect of it is that it is extremely fragmented. So it's a very specific way of describing the ANR, and it doesn't really give developers the information that they need to better prioritize. Most often, the first question that a developer wants to answer is it my code or is it someone else's? And there isn't a quick way to do that right now. For the next topic, the information that developers are given to resolve ANRs is insufficient. So I'll take a step back before I go into everything on this slide. Developers are given a stack trace to solve an ANR. Historically, with crashes, they're given a stack trace as well, but it's an exception. So it means something in the code is broken. For example, 1 + 1 = 3. That's very specific. In contrast with ANRs, you're given a stack trace to solve a problem where the app is frozen. And somewhere in this 5-second interval or more, you're capturing a stack trace in a moment of time. So it's very possible that you capture the stack trace a little bit too early or a little bit too late. What is the likelihood that whoever is capturing the stack trace captures it at the exact moment that you need to get you to the root cause of the issue? It's not that likely. We all try to do it, but the problem is that it's very hard to do. So the information that developers are getting, one, they actually don't know if it's the right stack trace. The second part of it is that when they display stack traces to mobile developers, they're showing them one at a time. So imagine if I have 100 stack traces and the first 10 are actually captured at the wrong time. And it isn't until the 11th stack trace where you actually get closer to code. In that situation, a developer is looking in the wrong direction 10 different times before he gets to the 11th stack trace, if he even gets there. And so you're letting engineers spin their wheels in trying to determine what's happening. And lastly, all they're given is a stack trace. They're not even given the context so that they can determine whether or not a stack trace makes sense. They're not given any context as to what led up to that problem. They don't know what views they were in, what taps that they did, where they were in the game. And so they're missing all of this context. So compound that all together. One, it's possible that Google is capturing the wrong stack trace. Two, they don't have the context to determine whether or not it is the right stack trace at all because they're given the stack trace in a vacuum. And then third, it's presented in such a way that they can't tell if it's an outlier. If you're looking at things one by one, you can't see whether or not it's an anomaly. Ideally, you want to see it all aggregated. So what's a better way to solve ANRs? I'm going to talk through the thought process of how to think about solving ANRs before hands hit keyboard. This is derived from best practices of mature apps and gaming companies. So first, I want all mobile developers to change their perspective on this. It's not actually going to be the same way that you go about fixing crashes. Typically, when fixing crashes, you go down the list and you see which is the crash that affects the most number of users, and you go down, you create a ticket in Jira, and you solve it, and it gets resolved. This is a bit more complicated. Like I mentioned before, this is a balance of business and of the technical issue. And so both of those factors need to be taken into account when you're resolving this. Instead of a checklist, it's actually an optimization. You want to optimize for revenue. You want to see which option will get you the most money, which option will get you the best user experience. So it's not a fix or not fix. You want to think about what is the best way to fix it. And so in order to do that, you need to understand your users and how they spend money in your app. In this slide, I've highlighted OS version and country because when doing an analysis and a comparison, that's when we see a better correlation between high ANRs are happening more on older OS versions, and specific regions are affected by ANRs more. But really, you want to understand how the users are spending money in your app and who is spending money in your app. For example, if you have an ANR that is affecting users on OS 7, do you address it? And the answer is it depends. If a lot of your revenue is coming from that user group, then yes, you do. And if not, maybe you go about solving it in a different way. But without this information, engineers aren't able to make the trade-off. They aren't able to say, if I solve this problem, it will take me 1 month. Is that worth it? In some cases, it is. But without that information, engineers are left to kind of solve extremely difficult problems when there are other ways to go about solving them. And so really what it comes down to is I see the optimization as levers to fix the problem. There are different things that you can do in order to resolve ANRs that don't necessarily entail you solving it. So what you can do, for example, is if you have an ANR with a specific feature that is really affecting old OS versions, you can ship a different experience. Because, for example, if those old OS versions are not providing a ton of revenue, maybe they don't get that feature because it is causing ANRs and it is negatively impacting you. And so you decide against it. It's also possible, and I've seen this before, where people have pulled out of certain markets because they are not able to provide the help that they need in order to troubleshoot those issues. And so people have pulled out of specific markets because it's been harming their Play Store ranking. And the other aspect of it is if it's your vendor, can you limit the use of that vendor or replace that vendor entirely? It's possible that it's not even your code. And so to kind of tie all of what I said together, I wanted to go through an example of an ad provider causing ANRs. And so we changed the way in which we present ANRs. We show them by package. And so it made it very easy for people to see which ad providers floated to the top. And so when we were first demoing and testing this out with users, we said, hey, let's take a look at this package list. Let's see what's going on here. And for two different customers, one of their ad providers, the same one, floated to the very top. The two of them had a very different reaction to it and how they responded to it. To kind of frame this conversation, ad providers don't have the same incentives as you as a mobile game developer or an app developer. An ad provider is trying to show as many ads as possible. They don't care how it affects your app. Oftentimes, if you let them get away with it, they will load as many ads as possible at startup, causing a long startup time. So the incentives for an ad provider and a game developer are often not aligned. And I think to kind of explain why the ad provider floated to the top, this is pretty common. I expect that if you were to structure your ANRs by package rather than by method, you'll be able to see it very quickly. It became a very obvious problem where it used to be hidden when it was by method because maybe another method was prioritized higher and this ad provider didn't come up. But when we categorized it by package, it was very obvious. So when they were looking at this, they took a look and they approached it in this way. One, they wanted to see what user groups were affected. Were there older OSs that were affected, or was it across the board? Second, what they looked at was how much revenue is this ad provider bringing in, and how much revenue would the competitor bring in? For one customer, they just decided to replace it. They said it's not worth it. It's a widespread issue. It's affecting a user group that we get a lot of revenue from. And if this is going to affect our Google Play Store ranking, it is not worth it. I'm going to go with another ad provider and test first whether or not they have just as high of an ANR rate, but I'm going to go with another ad provider. The other customer took a look at it and said, look, it's really impacting older OS versions. And what we want to do is swap out a different ad provider for those versions. This ad provider does very well with our core group of users that pay the most. And so we are going to keep them. So this is what I'm talking about when I'm saying it's an optimization problem, and that you have to take into account these factors of revenue, how much money this ad provider is bringing in, how is it affecting your user base, which user base is it affecting, and then also how difficult is it to solve this problem.
Okay. Christine, that's a great way to think through how to approach ANRs and addressing them in a way that aligns both the business and engineering to a common end. Now, let's imagine you've gone through that decision matrix and came to the conclusion that ANRs are your fault. What's next? One approach that our customers take is to look at individual sessions and try to see how ANRs get triggered in the wild. What I'm showing you here is a screenshot of a session with an ANR and the embedded stack trace. We talked earlier about the power of seeing our ANRs in context, and this is what we meant. You can see the views that the app entered, the networking calls, and the ANRs all in a user timeline that represents what the user actually experienced. I'm sure everyone here has had the experience of an executive escalation or trying to track down a reported problem from a high-value customer. it's really powerful to be able to see their ANR in the context of what they actually experienced. However, like Christine was saying, your engineers don't have time to look at every single session and every single ANR. There must be a better way to tackle whole classes of ANRs based on business impact. So I'd like to introduce you to our new feature, flame graphs. Flame graphs were created by Brendan Gregg. You can read about them on his website and watch some of his talks that illustrate the power of the flame graph visualization. I'll just read a quote from his page. Flame graphs are a visualization of hierarchical data created to visualize stack traces of profiled software so that the most frequent code paths can be identified quickly and accurately. Okay, that was a mouthful, even for me. In other words, what we're looking at is commonality. So you'll see in a minute that the longer bars equate to more common methods. Another way to put it, a flame graph visualizes stack traces in a way that you're basically smashing them all together and then sorting by frequency. And the stack traces basically are represented by every vertical slice. So let me actually just show you. It'll be more clear if we move into a demo. So I'm going to go off screen here. Okay. So this is the Embrace dashboard. This might be the first time that some of you have seen our dashboard, so let me briefly describe what you're seeing. The detailed user session that I showed you previously would be located here in the user sessions area. The tabs below, crashes, out of memory, ANRs, these are basically aggregations and insights pulled from the user sessions above. Okay, so on this page here, what you're looking at is our ANR summary page. Like we discussed, you want to be able to determine right away whether the ANRs in your app are coming from your own code or third-party packages. Part of our new ANR feature is right here with this list of packages. Instead of showing you ANR sorted by most likely method, what we're showing you here is a list of packages which have been aggregated from all of the stack traces in the dataset. At the top of this list is com.app.app, which is a first-party code in this example. Below are a bunch of third-party packages, ReactiveX, Google, mParticle, etc. Christine went through earlier how valuable it would be to determine whether your ANRs are coming from first-party code, third-party code, an ad SDK, or whatever, and this package listing helps you determine that. Let's say you swap out an ad SDK. These stack trace and session percentages will help you determine how much that change moved the needle. Okay, so let me show you. If I click on this ReactiveX, I get to this page here. Okay, welcome to the flame graph.
So I'm going to pause Ed right here. This is extremely overwhelming. Every time I have shown this to someone, their first reaction is, oh, what do I do with this? So Ed is going to, I know it feels very daunting, but Ed is going to break it down in a way that makes sense, I promise.
Okay, thanks, Christine. So like we discussed earlier, what you're seeing is a smash up of all stack traces in this data set. And this data set is basically these 5 versions for the last 24 hours. There's these other two options here we haven't talked about yet. So the Embrace SDK will ping the main thread every 500 milliseconds. So our ANR sensitivity is actually much greater than what you'll see in the Google Play Store. So let me set this duration to 0 so we can see even the short-lived ANRs. Secondly, Embrace is capturing data continuously, so we can actually group by first sample. Our customers have told us that it's actually more useful to see what's running when an ANR first begins, rather than when it exits. So we like to group by first sample. Okay, so here, before I zoom in, you can kind of see, if I scroll down a little bit, like these vertical slices, these super thin lines are basically individual this is an individual ANR. And in this page, you'll see this x-axis, we're looking at over 1,000 ANRs here all at once. It looks like my screen is melting a little bit. So what I can do is actually zoom in. So let me zoom in on this. We're looking at a left heavy view. So let me just scroll over here, zoom in a little bit more. Okay, all right. So if I hover over this top one, zygote init.main, you'll see it's across in this data set, zygote init.main shows up 98% of the time. And that makes sense, right? I mean, like even in the screenshot that I showed you earlier, zygote init.main was part of that. Okay, if I, as I go down, this runtime init, 74%, well, you can't totally tell, but the bars do get a little bit smaller. It's kind of off my, the zoomed in part. Okay, but what you want to do, like if let's say you're an engineering manager, maybe you're an engineer, you want to spend your time in the most valuable spots. What you want to do is start looking at like these longer bars. So just imagine you were spending your time on this tiny slice down here, or one of these thinner slices. Like that's a real stack trace. Like someone actually experienced a problem there. But if you solved it, would it move the needle? Maybe for that one user or for that small collection of users. But imagine you knocked out one of these longer bars or these wider bars. The impact would be just so much bigger. So how would we actually look at this? So as you go down this code execution path, you'll see right here, this main activity view model. This is probably where your code comes into play. It happens to be com.app.app, so we know it's first party. And 74% of the stack traces have this execution. So am I saying this is a wrong thing to do? Like, no, but it's just an indication of where you may want to spend your time. Okay, if we go down a little bit, let me zoom back in a little bit. You've got more of this main activity, session initialized. I mean, obviously you wanted your session to be initialized, so that's probably fine. But it is a long bar, so is there a more efficient way? Is something else getting initialized? It would be a good place to look. Let's see. And then let's see, here we go. You have a lot of inflation here, and it shows up here as well. Like everyone knows that inflation is a single threaded process. So it makes sense that you would have inflation show up in your ANR stack traces. I'm not saying, again, like everyone uses inflation, it's how you lay out your pages, but there's a lot of calls here. Is there a more efficient way to lay out a page? Maybe, but again, it would just be a, something, an area just to look at. Okay, so that's our ANR feature. It's a two-part feature displaying the packages that show up most frequently in ANRs, and of course, the flame graph view of all the ANRs in those packages. So Christine, I'll turn it back over to you for the wrap up. Let me just go back to a full screen here. And back to you. Say, Christine, I think you're unmuted. Or you need to unmute.
Thank you. So we're going to talk about the key takeaways from this webinar. First, I think it's important that engineering should have goals that align with the business. If reducing ANRs is important to the business, engineering team should be measured and held accountable for this metric. Second, when resolving ANRs, we want to take into account both the business and the technical factors and identify the levers in solving the problem. It's not really just a straightforward fix the ANR. There are multiple ways in which you can approach this problem. Third, more from the actual mobile developer side, is you want to identify problematic vendors. If they are a main culprit of your ANRs, you want to either have them fix it or replace the vendor or come through come with a solution like use this vendor in certain situation. And lastly, when it comes to evaluating ANRs, you want to find a way to display it like flame graphs that will reduce the noise. When you visualize all of the stack traces together, like in a flame graph, you're able to see what is not important or maybe what might be an outlier. So try and find a way to visualize all of the stack traces together.